So the question that was given to us was transforming retail supply chains from inventory management to last mile deliveries. What we are planning to implement is scaling the application for millions of customers, a real-time performance, data residency, and the integration of agentic AI into a uh, project so that our project takes care of everything from inventory management to last mile deliveries. Here we are using 8 services. The services which we are using are given in this an API gateway to connect with our front end, an ordering service, a warehouse service, a notification service if anything goes wrong, a delivery service which delivers keeps tracks of every delivery, an inventory service which keeps tracks of the inventory for every customer, a forecasting service which takes care of the demand forecasting, an agentic AI service which helps in various optimizing and other purposes, and a Postgres database for storage of the customer ID and the various types of stocks present under that customer. So, first of all, what is the main problem we are solving? We are solving the retailer stock management and problem, which is very common, where the retailer is faces problem in its stock management. Also, giving a demand forecasting that's for the retailer, such that the retailer can take care of how the demand may increase or decrease, such that he may increase or decrease his stocks accordingly. We also keep a warehouse stock management and a last mile of route optimization plan and an event tracking plan. So how we are going to solve this problem? We are going to solve this problem with the help of a very front end. So for example, the unified cloud, we first of all in stage one, we are using Nest.js as a backend, and using a Nest.js, we are creating the backend on it. After that, we are using TypeScript for scalability and ecosystem. And for the front end, we are using Next.js framework. So this is for the tech stack. Next, let's move on to the next part. So for the next part, we are moving on to the UI. So the UI will consist of a dashboard for admin panel, which consists of the total inventory, which gets updated every 5 seconds for here. Obviously, all of the data here are mock data. The time of update may vary. So the deliveries in transit, as you can see, it gets updated in real time, which shows the admin whatever the delivery that has dispatched from various warehouses are in real time, and what are the anomalies detected in the events that proceeded. So the inventory levels of various warehouses and various types of products are given here at real time if they increase or decrease. Everything is given in a uh, fashion such that the user can understand wherever his the orders are and how much stock he has in the inventory. We have also integrated a map such that we can keep track of every type of order ID. For example, when we hover over a route, we get to know about its order ID and what type of delivery system, transit system we are using. For example, for red, we are marking it by flight. For green, we are marking it by train, and for blue, by truck. Next, we come of the real-time orders. Here, the real-time orders, we can keep track of the order ID. For example, if we click on this order ID, we can see that the map gets zoomed in to the path of the order ID, and we can take care of all the part type of that order. Next, we come here, the status, as you can see, the status changes from processing. There is three statuses. There is a shipped status, there is a processing status, and there is a delivered status. So these three statuses are there. For example, if its rent is due, then the user may also pay the rent now. So these are all for the dashboard. Let's next go to the demand forecast. So here The demand forecasting basically uses a tariff max model, which basically takes input from this forecasting service as backend, which may be uploaded in AWS services in stage 2. For now, we are keeping the backend services in Docker Desktop or in Docker Hub. Now I am running it from Docker Desktop, and after the stage 2, we are planning on implementing or uploading the full backend in AWS consoles. The front end will get hosted in Firebase console itself through Firebase hosting. For example, here the predictive demand forecasting, we can monitor every type of goods that are present. For example, monitor the historical data, what type, how many months the historical data the user wants, and for the how many periods for the next how many periods does he want the forecast. On clicking on generate forecast, for now we are using mock data, and as you can see that the forecast is generated. The forecast is generated, which gives the user a detailed overview of how much is the upper confidence and the lower confidence, and how much is data will change. It changes everything here. And upon this, he can make his orders. So let's go to the next part. Let's go to the operational analysis. Let's see how the operational analysis works. The operational analysis is nothing but a real-time event stream which takes care of all events that are popping up. And through an agentic AI system, we can detect them as anonymous and suspicious events. For now, we are using mock data for this. As you can see, as the suspicious and anonymous events are getting filtered, they are getting in this flag queue. So after that, we can analyze these flag events. Let's analyze these flag events. For example, first of them, there were five. So every flag event has an anomaly and a suggested action given for that. So according to this, the user can take care of whatever he needs to do and for that event. And according to that, he may implement solutions. Now let's go next part to the logistic optimization. So basically, the logistics optimization is basically an agentic AI system which takes care of every uh, route that comes into its path. Here is an overview of what I'm talking about. An agentic logistic optimizer is an AI agent to orchestrate logistics, optimize rules, and handle exceptions with human in the loop oversight. So, for example, we take in the origin and the destination, and it takes into consideration all the warehouses that we have and every service that are currently present, and we are currently subscribed to. So, all the services that we are currently subscribed, if a retailer is subscribed to two services, then he can take that into consideration, and after taking that into consideration, he may give an optimized rule for the fastest and the lowest cost delivery for that retailer for that type of good. And using that, the retailer may order from that type of service. The retailer has an option to reject it and to choose it. It also gives an estimated distance and an estimated times, and also shows here in the map the estimated path that we are taking. Why we are using it? Basically, we are using it for AI reasoning. This route is and the reasoning, the route summary, and the estimated time and the estimated distance. Once the route is confirmed, he can finalize. For example, the package contain he can give like laptops, and this package contents will get here auto filled like the contents of the laptops if they are present in the nearby warehouses, then they can take that into consideration, and let's go take that into consideration and optimize the. So after placing order, we place a payment first and the overestimated cost and confirm and pay. After that, here it comes as processing like new logistics order, And this order is expected, and when it is ordered, it's ordered today, and when it is expected to reach, and now then it gets shipped. So we can track the order with here, and you can see that the order is shipped and the order is coming from here to here. So taking that into consideration, we can also pay here the rest of the money. So this is a brief overview of the admin panel of the UI. Let's go to the customer panel. The customer panel will look something like this, where every retailer who is a customer of a service gets to see everything that he needs. And he sees that what is the status of each and every stock here in the inventory. And if anything is out of stock, he can go to forecast demand and may take into consideration how much demand is there for that stock in the next amount. He can also manually add a product name, the company quantity, and the weight and the dimensions of the product comes to him. And also these weights that are here, they change according to the products or the type of products that come. Basically, blue means that it's stale, and yellow means that it is in critical conditions or it needs it's in low stock. So let's go to forecast demand for this mechanical keyboard which is out of stock, and let's go uh, and mechanical keyboard. And let's generate a forecast for this. Let's see how much it's for the next 12 months. So for generating the forecast on this, we can see that the retailer sees that this is the forecast for this, and using an AI agent, agentic AI system, we see that what is the recommendation from it. The user gets a recommendation like based upon the forecast, you have a potential shortfall of this much amount of units of keyboard shortage according to the demand that will come in the nearby future. You have this much shortage units of mechanical keyboard. So if you have this much shortage of keyboard and this much is the forecasted units, means this much amount would be needed over the total 12 months, then the AI will urge the user to place an order for this much amount of units as the current stock is zero. Or the user may tell that no, I don't want this type of forecast, and please redo my forecast. Then if he wants to redo his forecast again, generate his forecast again, he may click on edit forecast. Or if he wants to place the order for this amount of units which the AI has suggested, according to the demand forecasted for the next few months, according to the Sarimax model, he can place an order. So when he place an order, he goes to the logistics optimizer. According to the logistics optimizer, the order type and origin and the destination he has to select, like which one where he wants to it's to be shipped, and he optimizes the routes. So route optimization means that the destination is fixed and the origin is also fixed, but but that the destination is fixed, but the origin is not fixed. For now, we are taking a mock origin, but the AI agent will take the destination into consideration and will predict from which origin the good has to come such that the retailer pays the least cost and the good also arrives in the least time. I repeat, the origin is not defined. The origin has to be calculated with the AI agent. For now, we are using mock data. The destination is confirmed, and upon that, we will optimize a route that from which warehouse the good will come such that the path is the shortest and the price that the retailer has to pay is also the lowest. Then we go and accept the route. It stores a route and we finalize and place the order. So you can see the package contains is this much order of mechanical keyboards. We go and place the order, confirm and pay. As you can see, here is the order path, and you can see that it goes as processing, and after this, it will go and process the orders. This thing is given in the admin panel as when a customer, let's say Mason Rodriguez, which we are using, taking into consideration. First, places an order. His order gets named by customer, and if an admin panel goes and places an order, his order that comes to his warehouse gets as a new logistics order. That is, this order is used for filling up the inventory of the warehouse, and this order comes from a customer or a retailer who wants to shift goods from his warehouses to his destination. The origin of the goods or the warehouse will be selected on the basis of the AI agent as given earlier. He also has an operational analysis given for the user. So the customer can log in with his login credentials, and each customer's data is private. So this is the front end part. The back end part is that these are the services. For now, I am showing a few services like let's take into consideration the inventory products. Okay, so let's take into consideration the inventory products, and so this is here. I will just make the request post, and the authorization key is given. The body is given. Let's take a body and let's take this, for example. This is the good that I want to send to the warehouse. So if this order I want to add to my warehouse, I will just send it. Okay, invalid token. Just a minute. Just a minute. So as I was saying, that I've taken into consideration the authorizations for the customer, which I get it from here. And after taking that into consideration, we will just give it a go. Right. Let's send it. It should work. Yes. As you can see, it worked correctly, and this is given, and we get an ID for our order. Right? That's nice. Now let's go back and place a few orders for our product. This is the order. And this is the JSON file that I want. Take that into consideration. And this is, let's put the order ID. And once I put the order ID, just send it. As you can see, my order is created for one. Similarly, I can do it for various others. So sending it, as you can see, another order is placed. It's simple. This all things are coming from my backend, these services which are running. As you can see, these are there. And